Hi, everyone. Thank you for coming to my talk today at this PM3 workshop. My name is Jermaih Joseph. I am a second-year master's student in medical biophysics, supervised by Dr. Karche, Dr. McIntyre, and Dr. Goldman. Today, I will be walking through a tutorial on how to non-interactively visualize using Paraview to save both time as well as computational resources. So I'll get started by sharing my screen. So the first thing that we see here are two terminals that I'll be coming back to. So on the left is a terminal that has my local disk set up, which is in a folder housing 100 BTU files, so a number from 0 to 1,000 in increments of 10. This is just a subsample of a larger simulation done on the supercomputer cluster Compute Canada. And I am currently logged in on the right terminal in a directory that has all 10,000 of the instances in increments of 10, so a total of 1,000 files. So I've taken 100 files from the cluster and brought to my local disk. And so the goal is to be able to visualize all of these BTU files as PNGs and preferably as a full animation, but to do it in an efficient manner. So the first thing I'm going to do is open up Paraview on my local disk. So if I open Paraview, so now that Paraview is open, the first thing that we're going to do is go to the tools bar and we're going to start trace. And so what tracing will do is now it's going to track each action that we perform, any more properties that we change, and save those so that they can be redone through other files. So now, once you click Start Trace, this pop-up to show up. We're going to click OK. And now everything that we do here is now will be saved as an action. So we're going to open first one of the files that we desire. So I'm going to choose any of these. So maybe like 750. I'm going to click Apply. And now we see this 3D structure show up here. And so from here, we can apply any filters that we want. I prefer to add a calculated filter. And the purpose of this is to change the pressure values to millimeters mercury. So I'm going to go to pressure. I'm going to divide that by 1.33 and pressure and so now once I click apply, these values will change to millimeters mercury. So now some other changes have to be made. First, I want to change the background to white. Okay, and once I do that, the legend text becomes invisible because it's also white on white. So first I want to move it to where I want it to be, the legend, and I'm going to now go to the legend properties, and I will change the text to black, as well as increase the text font. Click OK, and there we go. So now the pressure millimeters mercury, and it's black and in large letters, sorry, large numbers. I then want to increase the color bar thickness because it's too thin. So I'm going to change that to 36 as well. I'll click apply, maybe a bit more, 50. There we go. And that is good for me. So I'm going to click OK here. And now lastly, the orientation axes labels also have a font color of white. So we're going to change that to black. Click OK, and there we go. So now this, I find this as acceptable. So I will now save this screenshot. Oh, before I do that, actually, one thing that I remember is that the pressure values that you can see in each image will vary between all the different BTU files. So I want to set a custom range so that they're not all changing. So I will go to rescale to custom range, and I'm going to choose from, let's say, 20 to 150 total. I'll click rescale. So now the values are all from 20 to 130. And if I don't want it to be in scientific notation, I'm going to turn that off. And so now numbers make a lot more easier to read and in a range that will stay consistent throughout all the images. And so from here, I will now save the screenshot. I'm going to give it a name, say 3D for viz. It's going to save as a PNG as desired. I'm going to keep all this the same and click OK. So now that's saved. The last thing I want to do is to delete the data that is in our pipeline, and so remove it from memory so that once we start iterating through all of them, they're not all stacked on each other and taking up too much memory. So we delete the calculator filters and the original. And now from here, we're going to stop trace. And once we do that, the actions and the trace all come as a Python, in Python syntax, and all come as a file here. So what we're going to do here is we're going to save as, and we're going to save this as the visualization script, and this will save as a Python file. So before we can start using this on the cluster, there are some changes that have to be made. So we're going to go to our favorite editor. Mine is Adam, and I'm going to open up that Python script. So this is that script in the folder, and the first thing we're going to do is we're going to Control F users. There's two results that we're looking for. So first is the first action where we open up the V2 file, so 750. As you can see, we are providing a full path here to get this file, but we aren't guaranteed to have the same exact path on cluster. So we're going to remove that path and just open this V2 file. So as long as this script is in the folder with this V2 file, we shouldn't have a problem. The next Control F that we did for the users is the screen where we save the screenshot. As you can see, this also gives the full path as well as the name that we want to save it as. But we don't need the full path there, we just need the name to save that, and this will save in the same folder as Python script. Now that that's fixed, we will also have to make one more change, and that is uncommenting line 19. And this just ensures that the view size is the same as what we've done on our local disk. And this helps me, but it might differ for others. So give it a shot if needed with and without commenting this. Now we save this file. We're going to go back to our terminal. And we're gonna, on our local disk on the left, we're gonna ls right now. And so two new files will come, this Python script as well as the PNG. So if we just open up this 3D for this PNG, we see the image just how we expected it to be. So I will now be running this Python script on my local disk. So before I do that, I'm going to rename this current PNG to 3D from GUI. So now that file is renamed so that we're not overwriting that file when we run the script. And so I'm going to run the visualization script, which is using the command pv batch. So what pv batch does is it will run all the commands using the Python script. So we're going to feed it this Python script now. Before we do that, I'm just going to time it to see how long it takes. So we'll come back when this finishes. There we go. So it took 2.32 seconds. And if we ls here, we see now that this coronary file has also showed up just as we expected. So we're going to open that PNG, and there we have it. This thing. So using the Python script, this is made the same way and what we expected from the other file. So now the task is to try running this on the cluster. So to do that, we will have to secure copy this visualization script to the cluster. So let's find this path. There we go. So the ls and we look for, there we go. So the Python file is now in the folder with the entire all the simulation results. So just as we use pv bash on the local disk, where we are going to do the same thing on the cluster. However, one small difference here is that we have to load modules onto the cluster. So these modules I have written here. That is the standard environment 2020, GCC 9.3.0, OpenMPI 4.0.3, as well as Paraview Offspring 5.8.0. As mentioned before, the version, the Paraview matters here to take into account our local disk. So let's copy this. Let's go to our cluster, and we're going to load all these modules in. And everyone. So now PV batch is ready to go here. So we're going to run the visualization script using PV batch, but we're also going to time it on the cluster. Sorry, on the Compute Canada. So there we have it. So it took 2.79 seconds here. And so if we look for the PNG here, it exists on the Compute Canada, but we cannot open it from there. So what we have to do is we now have to bring it back to our local disk. So what we're going to do is just clear copy and get this directory as well as and we're going to bring it back to the parent folder so that we're not overriding the file here already. And if we open that file, there we have it. This is the file that we've taken back from Graham, and so that's great for one file. However, what we really want to do is to be able to go through multiple files at once. So in order to do that, we have to go back to our script, our Python script, and this from line 11 until the end, everything has to be highlighted and tabbed once. So we're going to tab all of it once, and we're going to insert a for loop here. And what we're going to do is we're going to iterate instead of just doing number 750. We're going to go from any range that we desire. So we have to give this range three values. So let's do from 0 to let's say 100. 0 to 100 in increments of 10. So 0 to 100 in increments of 10. I'm going to close that with a colon. Now, we're going to replace the 00750 with with the I value that we get from before. And to do that, we're going to put %05b. What the %05b means is that we're going to have 5 characters with leading zeros before we have our first number. This is just to match the format of these file names here. So after the quotation mark, we're going to have to give it a % space I in round brackets. And so this is when we open each file. So we're going to iterate through each of these numbers from 0 to 100 increments of 10. But we also have to save each file with the same number corresponding to what we open with. So we're going to go back to our save screenshot line. And here, after the viz, we're now going to insert the %05d again. And after the quotation, we're going to give a % bracket I close bracket. Now, this script is ready to be sent to Graham again. So we're going to go to our terminals. On the right-hand side in Graham, we're going to remove the existing visualization script as well as the PNG. Now it's just the VTU files. And this new visualization script, we're now going to send this to the supercomputer. So we've already done this one. So let's just go back there, click enter. And now this visualization script has shown up here. So what we're going to do is we're going to time it again, one PV batch, and feed it the script. I'm going to click enter, and we'll see how long this takes. So 12, 14 seconds. So this right now I've done from 0 to 100 in increments of 10, and that took 14 seconds. But I need to go from 0 to 10,000 later on, in increments of 10. So that'll take about 100x that. So if you do the math there, you can kind of comment how long it will take to go through all of the files. However, we now have a set of PNGs in the folder on RAM, and that is 10 files, 10 PNG files here. And to make it easier to bring them back, we're going to make a new directory here called output 3D output PNG. And we're going to move all the PNGs to 3D output PNGs. After CD to 3D output PNGs, you see all these PNGs here. And now all we have to do is secure copy this entire folder back to our local disk. So I'm going to do that here. So I can do it recursively because it's a whole folder. .ca, get this entire folder. And oh, sorry, I forgot to indicate where I want it to be. Say a secure copy to. I'm just going to secure copy to the current folder I'm in, and we're going to let that copy in. And once that's done, we're now going to go into that folder. 3D output PNGs. There we have. So all the PNGs we've taken back, all 10 of them taken back. So we can open any of these. I'll just open this one. And this is what comes up. So as you see, the legend is consistent and the color has changed a bit. And so we have 10 of them. The next step we can do here is to combine all the PNGs into a little animation. And so in order to do that, you have to type in, you have to use something called Image Magic, which you can download for free online. And the command from Image Magic is convert dash delay. We're going to get a delay of 0. We have to feed it all the PNGs. So 3D, and we're going to give it all of them a PNG. We're going to loop it forever. And we're going to name it animation.gif. So we're going to let that run. That'll take some time. But this is only for 10 PNGs. And so doing it for more than that will take a bit longer. But now that this is done, we're going to go to our Finder. I'm going to look for this animation.gif. That's in this output folder. Animation.gif is right here. Might be a bit difficult to read because it's quite small, but I'm opening the GIF using Google Chrome. And there I have it. It's a really quick, very small, short animation for the visualization. And so that saves us a lot of time instead of letting the graphical user interface do all the calculations and the saving for us for all these PNGs. This makes it much easier, especially, it'll get especially easier when you're working with, like for example, all 1,000 or 10,000 files that I want to visualize. So I hope that that helps you guys understand how you can be more efficient with your visualization and being able to do it non-interactively in a more time-efficient way and communication efficient way as well. Thank you for listening, and if you have any questions, Dr. Carter should be able to answer them here on. Thank you.